Okay, so we're going to do your notes over triangle angle theorems. If you are at this point, that means you have already completed your Exploring Triangles lab. So this should be kind of repetitive. The angle sum theorem says that the sum of the measures of the interior angles of a triangle is. This is the same question you guys have seen several times, but the sum of the interior angles is 180 degrees. So for example 1, it says find the measure of the third angle of a triangle if the first angle is 66 and the second angle is 37. Well, if you need a picture, you can draw one, so you can draw yourself just a basic triangle. One angle would be 66, the other one would be 37. They're asking you to find this one. So what you would need to do is add 66 plus 37, and then plus this last angle, which we would call x, and it would be equal to 180. So if I add 66 and 37, I would get 103. So I've got 103 plus x should be 180. So then I need to get x by itself. So I would subtract 103 from both sides, and I would get that x is 77. So the third angle, or the measure of angle 3, would be 77 degrees. So example 2. This time it gives us a picture. And it says find the measure of each angle of triangle RST. So if this is the picture that we're looking at, we go ahead and set up the same equation. Now I know up here it gave you numbers and it would have been really easy to just add them together and subtract from 180, but I was trying to get you to see how to set it up. So basically we would say the measure of angle S plus the measure of angle R plus the measure of angle T should add up to 180. So I'm going to set that up, but now I'm going to plug in. The measure of angle S is x, so I would say x plus R, which is 3x, plus T, which is x plus 40, should all add up to be 180 degrees. So we need to combine like terms on this side. We have x, 3x, and x. So total, that's 1, 2, 3, 4, 5 x's. So I have 5x, and then I bring down the 40, and that should equal 180 degrees. Now I'm trying to get x by itself, so I need to move the 40 over. So it would be negative 40 on both sides. So I have 5x equals 140. So then to get this by itself, I would have to divide by 5. And 140 divided by 5 is 28. Now look over here. Does it say what is x? It doesn't. So they actually asked us for the measure of angle R. So the measure of angle R, well, that's 3x. So if I replace x with 28, then I would do 3 times 28, and I would get 84. So the measure of angle R is 84 degrees. We do the same thing, the measure of angle S, and that's just x. So if I replace x, I just get 28. So then this is 28 degrees. And then I do the same thing with the measure of angle T, which is x plus 40. So that would be 28 plus 40, which would be 68. So over here I would have 68 degrees. So now you could double check on your calculator. If you see, I've been doing some of the math on there. 84 plus 28 plus 68 should add up to 180 degrees. If it doesn't, you messed up somewhere, okay? But in this case, it does. So let's look at the very bottom. There's some extra information down here. So I've got the angle sum theorem corollary 1. That just means extra information about angle sums. Each of the angles of an equiangular, remember this means all three angles are equal, have a measure of 60 degrees. And you should have found that out during your Exploring Triangles lab. The second one is that the acute angles of a right triangle. So here's our right triangle. The acute angles, this one here, angle 1 and angle 2, should add up to 90 degrees. And again, you should have seen this in your lab. So when two things add up to 90, they are called complementary. We've been doing a lot with supplementary, which means that they add to 180, but this is complementary, which means it adds to 90. So let's see if we can use those two theorems to solve some other problems. Sorry. So here's example 3. Find the value of x and the measure of each acute angle. So down here, it should have actually asked you for the measure of angle J and the measure of angle K, or sorry, of angle L. So when we go to solve this, we just talked about the theorem that if this is a right triangle, that the other two angles should be complementary. That means the measure of angle J plus the measure of angle L should add up to be 90 degrees. So if J is 3x plus 2 and L is 2x plus 3, we should be able to set up our equation as so. So now we combine like terms. 3x plus 2x is 5x. Positive 2 plus 3 is plus 5. Now I'm trying to get x by itself, so I would subtract 5. That leaves me with 5x equal to 85. And then I would divide by 5. And we would get that x is 17. So over here I have x, but we have to make sure that we find the measure of each acute angle. So we would say the measure of angle J is 3x plus 2. So that's 3 times 17 plus 2. And you can just put that directly in your calculator. So 3 parentheses 17 and then plus 2 and then just hit enter. So we get 53. And then down here that would be 53 degrees. And then the measure of angle L is 2x plus 3. So if I replace x there and then do the same thing in my calculator, so 2 parentheses 17 plus 3, I get 37. So where I said the measure of angle L, you would put 37 degrees. And again, double check, 53 plus 37 should be 90. And it does equal 90. All right, let's talk about exterior angles. The measure of an exterior angle of a triangle is equal to the sum of the, we talked about this in the lab, two remote interior angles. What that means is the two that are the farthest away. So if I look at example 4, it says if x is 63 degrees, so I label my picture, and x, y, z, so that's this one in here, is 53 degrees, find the measure of z, y, r, which is this one right here. Now, there's two ways to do this. If they give you numbers, I'm hoping that you guys remember what this should add up to be. Okay, they're still a linear pair, so it should be 180. So you could just subtract. But what they're wanting you to do is to use the two remote interior. So the measure of angle z, y, r should be the sum of the measure of angle x plus the measure of angle z. These, x and z, are the two angles that are the farthest away from this one here. So if there's a total of 180 in here, I could use my calculator. 180 minus 53 minus 63, and I get 64. So that means z would have to be 64 degrees. So that means that the measure of angle ZYR is measure of x, which is 63, plus the measure of angle z, which is 64. So 63 plus 64 should give you 127. So this would be 127 degrees. So now let's double check our old linear pair idea. If I take 180 and subtract 53, I should still get 127, just to verify that I did get the right answer. Which I did. So we can either use a linear pair if they give us numbers, or if they give us this angle. But if they only give us the two remote angles, we can use those. All right, example 5. In triangle EFG, the measure of angle G is 100. FEH, so here's FEH out here, is 3x. 3 times the measure of angle F. Well, I don't know what F is, so I'm going to call it x. So that's why this would be 3x. And they want us to find the measure of this. So remember, this is that same setup. The exterior angle, this one out here, so the measure of angle FEH should be equal to the measure of angle F plus the measure of angle G. These are the two farthest away on the inside. So if I plug in, 3x should equal x plus 100. So to solve, I need to put the x's together. So I would subtract x and subtract x. So this is 2x equals 100, and then divide by 2. So I get x is 50. So the measure of angle F is x, which would mean that it is 50 degrees. All right, so flip it over onto the back. This should be very familiar to you, the isosceles triangle theorem. It says the base angles of an isosceles triangle are congruent. So what you need to know is that the base angles are the ones that are across. So if this side is congruent, straight across from that is this one. Straight across from that is this one. So that would mean that we would set these two things equal to each other and solve for x. On the bottom, this is just kind of a review. This is what I want you guys to finish on your own. Find the measure of each numbered angle. You will have to use vertical angles, alternate interiors, alternate exteriors, those kinds of things. Or if you notice, 180 degrees in a triangle, vertical angles, 180 degrees, linear pairs, things like that. So good luck, and when you're done, come get it checked so you can move on.